Okay. I think this is working. Right. Can everyone hear? So I think, oh wait, this is just webcam, and this is screen sharing with my recording program. So yeah, welcome everyone to the stream. So this is the second Wheatley live coding stream. The first one was, I think, a big success. Hey, people can hear me, great. So yeah, basically, what's this going to be? Well, basically, I just want to give people an insight into like what it's like to work on Wheatley. How does Wheatley work? Like, there's no black magic in Wheatley. It's all like it is all relatively simple, but it just all like comes together and makes something that it seems really intractable from the outside. So I want to kind of break that apart because yeah, the programmers tend to just be like, you know, people in their parents' house bedroom, you know, sitting on their own coding, and then you see the product, the final product, which hopefully works. But most people don't get to see behind the scenes. So that's what this is about. So on this side, no, this side, on this side of your screen, if you're on PC, and down below if you're on mobile, there should be a thing that says like chat, right? And if you type stuff in there, then everyone can see it, including me. So I'll be looking at that as I'm streaming. So if you want to ask me questions, or I've done something silly, or you have any suggestions or whatever, then bang a message in that I can't deal with the camera being the wrong way around, and I'll hear it. So if everyone says hi now in chat, just so I can see it's working, and yeah, I'll see how many people I hear. And then once you've done that and know everything's working, then I'll get on to actually doing some coding. So I'll wait. Also, there's a solid 10 or 15 seconds of delay between me between me broadcasting. Oh, first highs are coming back. So between me broadcasting and like people typing in chat and chat coming back to me is about like 10 or 15 seconds. So there's going to be a bit of delay between you guys saying something and me seeing it. Oh, thanks. Yeah, happy birthday for yesterday. It was my birthday yesterday, so I'm now 21 and a day. Okay. So yes, thank you, Roger. Right, okay, so we have classic code and Firefox. So basically there are two things. Oh, hi, more people are turning up. So there are two bugs that I'd quite like to have a go at today. And they interact with very different parts of the code. So they'll be good to kind of, if we can do them both. One of them might take for a really long time, in which case I'll do one. But they should have a decent split between like seeing more of the code than just like doing two things in the same area. So the first one, these are the like bug lists that Wheatley has. So the first one is making that's all act correctly, because at the moment that's all just forces rounds 2 rounds after, like 2 rows after that's all is called, Wheatley will snap back into rounds, which is that's not what you want. You want Wheatley to, well, of any ringer, right? You want to call that's all, and 2 rows later you want rounds, but you don't necessarily want to keep going until that. Like if you meet rounds sooner, let's say I call that's all as rounds is happening. In fact, we could do this. So let's say, right, it just comes round. Maybe it's 1, 2, 4, 3. Excuse my extremely childish handwriting, right? So we've got 1, 2, 3, 1, 2, 4, 3, 6, 5, right? And then we call that's all. So this is rounds. Yeah, I can't draw. 4, 5, 6. And so we could call like that's all basically anywhere, right? You could call it here halfway through rounds, right? That's all. And at this point, you would expect Wheatley to stay in rounds here, and Wheatley doesn't. Wheatley will carry on ringing whatever method it is, probably ring 2, 1, 4, 3, 6, 5. and then snap back to rounds at this point, because this is 2 rows after you called it, and Wheatley has like the 2 rows warning rule, but it applies to literally everything, including that's all. So yeah, basically that's what we want to change. So we want, whenever that's all is called, Wheatley should check and say, oh, that's all has been called. If we're in rounds right now, then just stop and don't do this weird like flicking in and out of the method bit. And otherwise, keep track of how many rows it's been since we've called that's all. Right? So let's say we called it on this row somewhere, then it would say, oh, this isn't rounds, because it's not rounds. So we've got to stop at some point. So we set the counter to 0. So this row has count 0, because it's been 0 rows since that's all was called. And then the next row we see, oh, this row is 1 away from that's all, and this is rounds. And so we'd expect Wheatley to stop. So this would go back into rounds. And it doesn't matter, we don't keep track of the fact that, oh, that actually we should end up taking effect here. That doesn't matter. In actual fact, it would be okay, but so many people call that's all in this row that it's just worth handling this as a case, right? Because it's really confusing if you call that's all in what you think is the right place, and then Wheatley keeps on going. Apparently, like that's what it looks like from everyone else, from everyone else's perspective. So at this point, with the new system of like keeping a counter, right? You'd hear that's all partway through this row, and then it's rounds, so you just stop, and that way we can have everything work. I'm not sure, this is far from the only way of getting this to work, but I implemented a counter system like this for entering and exiting methods. So like calling go and having up, down, and in, right? Making that handle backstroke starts properly was a bit of a pest, and I ended up implementing a counter like this. So this is bug number 1. The other one is it's almost not a bug, right? It's just a slight annoyance, shall we say? And this is that the rhythm system has a kind of flaw, which is that if so you know Wheatley can wait for people, right? That's a fairly well-known feature, that if someone holds up, then Wheatley will hold up over them. And this is just implemented as like a loop, that if someone hasn't rung it yet and they should have done, Wheatley just sits in a loop and waits for them. Okay, when I asked said that I would answer questions about anything, I didn't mean this, but okay. So Dominic, I can't, Montefiore, I hope I pronounced that correctly, says, would you rather have one of your feet superglued to one of your hands superglued to one of your feet, or both of your hands superglued together, and why? I think both of my hands superglued together, because I can do more stuff like that, because my hands are naturally close together, right? Like if I'm just like stuck praying all the time, then that's okay. Whereas if my hands are stuck to my feet, then that would be super annoying. But yeah, anyway, so back to the thing about Wheatley waiting, is that if people are very slightly late, right, or Wheatley sees people ringing slightly late, then the rhythm trick thing holds up very slightly. And I think this is the cause of Wheatley's striking being very lumpy. Because if people's internet is very ropey, so like holding up slightly every so often, then Wheatley really falls for that and goes, oh, when we reach when that person should have rung, like Wheatley goes, oh, they should have rung, starts waiting for them, and then maybe a fifth of a blow later they ring, then Wheatley will be the same amount out. And this is kind of annoying, and it doesn't really have to be that way. That was just the easiest thing to do at the time, to like get the feature working. So what would be more useful is that there's a cutoff, which is like if we see someone less than half a place out, then just ring in the right place anyway. And so long as that number's not more than 1, it's well defined to do that. because you just, well, I'll explain when I get to the code how this would be. But this is bug 2. And I think this bug number 1 is probably the easier one in terms of like how much of the code base you need to know in order to do it, and therefore the amount of the code that I have to explain. Because I'm going to start by explaining everything. If you are interested and want to have a look at how the code works, then there's a file in here called architecture, which basically, it's a written down version of what I'm going to say, basically. Which is like, well, it says it up here. It's like, it's a mental map, basically, of the code, which I would have in my head when I'm writing, but any new person to the code would have to, like, see it somewhere. So if you want that, I can stick a link in chat, potentially. But, yeah, if anyone wants that, I'll put a link in chat. So I think we should make a start on this, unless anyone really wants to see the other one. But the rhythm system is relatively complicated, and this is much more high level in the code. Right, I'll give people a few seconds to reply. But for both of them, it's worth looking at how the code works. It's just kind of high level, and I'll just like draw a neat little diagram. Or I'll try to draw a neat little diagram. Must be an easier way of clearing. But anyway, so basically, like, Wheatley as a human is pretending to be a human ringer, right? In essence. Of course, Wheatley's not, but we have to build Wheatley somehow. And the way Wheatley's built is that it's built into lots of, or 4 or 5 small components that get glued together and combined to build something that works, right? Or does what we want it to do. And basically, if you think about what a human is doing whilst they're ringing, you have kind of 3 things. You've got, you've somehow got to tell everyone else that you've rung, right? So you've got to have, do I have some text? Oh, I do, excellent. So you've got to have, you've got to have some kind of interaction with ringing. And this is, if we're talking about a human, this would be eyes, ears. Although eyes are strictly, like, not necessary. All you really need are ears, right? So all you need to know is what things are happening. And we need some equivalent of arms, right? And this will allow Wheatley to ring with other people. And then the second thing we need is we need some way of knowing what we're ringing, right? And this would be like, oh, are we ringing plain Bob? Like, and when someone calls a Bob, what does that mean? And this is basically just like, what order are the bells going to be in, if you like. So we need something that's like, what are we ringing? And this is going to be essentially like method knowledge. It would be for a human. And the final thing we need is we need to know when to ring. And I'm assuming that like go and stop, that kind of thing, counts as number 2, right? So what order the bells are rung in. We could probably say that more clearly, like what order are the bells. And Wheatley has to figure this out in real time for all of these cases. And then finally you've got when to ring. And this is essentially the rhythm, right? So as a human, we have a like innate feeling for like, oh, the bell's supposed to go exactly here. Parents. Okay, hold on, I'm going to shut my door, and then we won't get disturbed as much. Alright, back. So Wheatley follows, the construction of Wheatley follows these 3 parts, anyway. And in actual fact, in the code, there are a couple more components that aren't in humans. There's some kind of glue, which like takes these 3 parts that can all run independently and wires them together in such a way that they actually, you know, do something useful, right? Like, it's no good knowing what to ring and when to ring it, and being able to interact with ringing room if you can't do them all at the same time. And this is called the bot in the code. So any reference to bot will refer to this. Any reference to rhythm refers to this. And this is called row generation in the code. And this is tower, I think. But I'll label those later so that people know what we're looking at. And the last thing, hold on, what do we have? What am I missing? So the last bit of the code that isn't involved in any of this other stuff is there are a load of utilities. And these are like definitions of types that Wheatley can use in order to give like more flexibility and control than just using Python's data types. So for example, we have a new type for bell that's in bell.py. And this avoids like, what do you call a bell, right? Like, is the 12, do you call it T, right? Like T for 12, or do you call it 12 because it's the 12th, or do you call it 11 because computers start things with 0? So is the treble 0 or is it 1? Whatever. Like there are loads of questions, and it's really easy to just muck up and be off by 1, right? So we've got bell.py, we've got a similar thing for stroke.py, aliases.py, I think, as well, that's like, that's basically alias. Basically, if you have a complex type, then we give it a name in the code so we don't have to express big types all the time. So these are like, it's worth knowing that these exist, which is why I'm telling you that they exist, but they're not really, they're kind of taken for granted by the rest of the code. They don't do anything properly interesting on their own. They're just here to support the other 4 things. And I'll just note these next to this as what these are called. So what we called tower is interaction with ringing room, row generation, usually with an underscore, is what are we ringing, and when, so rhythm, the whole rhythm module is when do we ring, and the glue code is called bot. Because before we named Wheatley, the code was just called ringing room bot. So like the root class of the whole thing, and the kind of glue code that pulls it all together is called bot. Glue code to make Wheatley work. So yeah, I think this is everything. This is like a very high level overview of like what all of the pieces are, and kind of like what they do. So obviously when we're thinking about these 2 issues now, we can kind of decide, we can think about, oh, what pieces of the code are we likely to be expected to see, right? So for example, this one, that's all stopping at rounds. Well, this has nothing to do with interacting with ringing room, right? Like obviously you need to handle the calls properly. You need to know when that's all is called, but we're already doing that, so we won't have to change that. And it is technically to do with what are we going to ring, right? So it's clearly not this, not number 1. It probably is number 2, although in fact we won't actually interact with number 2, I don't think, because of details about how the code is written. It has nothing to do with number 3. Like that's all has no relevance to the rhythm, unless people stop because that's all it's called, whatever. But it will have a lot to do with 4, right? Because this is all about how we're gluing together the inputs that we get from ringing room, right? Which is that someone's called that's all, what do we do? And we need to decide, we need to have some effect in number 2 that's like, oh, someone called something, we now need to change what we're ringing, i.e. we need to ring rounds. So it'll basically be working with probably a bit of 2 and mostly bot. And so for the other one, for the other bug, this is all about waiting for people. So it clearly has nothing to do with what we're going to ring. Like, method knowledge has no relevance to this. Most of it will be number 3. We might encounter the glue code a little bit, but I find it unlikely because we're not actually changing how, we're not changing at a high level how the rhythm code works. We're just changing the details. So that's like an overview of these two. I think we'll start with this one because it's simpler in terms of like the amount of code we see. And it mainly involves the glue code, which is the easiest bit to understand because it just like talks to the other bits of code. So here we are in the code, and if I splat this out, oh crikey, it spits out a load of things. Can I get it? Here we go. So this is spitting out a tree view of the code. So we've got like the project root directory with architecture, which is the file I showed you earlier. And then we've got like basically all of this stuff. All of this stuff is not relevant, right? This is all unit tests, basically like testing the code, and a few other things that like user-facing stuff. The main bulk of the stuff is in Wheatley, the Wheatley folder. Anyone who's looked at the code will probably, and contributed, will have got their way around this. So we can see the parts that I was talking about here, right? We've got bot.py is where we're going to see the glue code, and that's what we'll be looking next. And then there's a couple of stuff that is all to do with like getting Wheatley up and running. So when you run the command or you press look to in ringing room or whatever, and we need, like, the code decides, oh, we need to ring at some point, then there's a big startup. There's a load of startup stuff that has to be done. That's kind of this chunk as well. And then we've got a folder for rhythm and a folder for row generation, which are the other two. Those are the two things, what we're going to ring and when to ring. And then finally at the end we've got tower.py, and this contains all of the code that interacts with ringing room. So nothing else, like this is the only file in the entire code that cares about ringing room and how ringing room is implemented. So it would be, in theory, quite easy if another platform came along, like, I don't know, Ding or something, Ding or Handball Stadium, although they both have their own quirks that makes this an oversimplification. We could just write another copy of tower.py and all of the rest of the code would stay the same and Wheatley would be able to ring on two platforms. I don't think that's going to be super feasible, and, you know, ringing room is the most common platform by far, so I'm not sure if that's going to be on the cards. But which editor am I using? I'm using Vim. So it's technically I'm using NeoVim, which is it looks exactly the same way as Vim, but internally the code is different. And I'm using a load of plugins that are taken from Visual Studio VS Code, and they basically implement VS Code's behavior in NeoVim. But, you know, like, tools aren't very important. I just have the muscle memory for this editor in my hands now. So, yeah, without further ado, let's jump into this. I'm going to change into this directory now. So if we tree again, oh, the tree didn't work quite so well. Okay, ignore that. That was not how it was supposed to be done. But we'll jump into bot.py now. Yes, it is Python 3 rather than Python 2. Although I'm not sure how much stuff will absolutely break if you ran Wheatley in Python 2. But yeah, Python 3 is like the way to go, as far as I'm concerned, because Python 2 is basically deprecated at this point. So it made no sense to start a new code base in an old version of a language. So anyway, yeah, here we go. We're in the code for bot, and we can see that we've got this class bot, which is it's what's called a singleton. So when Wheatley starts up, one and precisely one instance of this class will be created, and that will be the only instance that ever exists for the lifetime of the code. and we could just have all of these things. Like, this has a huge amount of internal logic, like the rhythm settings, like do up, down, in, stop at round, call, compositions, what username are we ringing as, all of this stuff. We could just have these as global variables, but it just makes our lives easier to kind of fit it into this, like put it all in one place. So what were we doing? Oh yeah, we were dealing with that's all. If I was new to this code base, I would probably search, and I'm going to search anyway. So this is what have we got here. Oh, callback. Okay, so this function is what gets called when that's all is called, when Wheatley is ringing. And it gets defined somewhere. Where is it? On that's all. Oh yeah, so in this is in it, I think. Yeah. So when the bot class gets created, this is like you run the Wheatley command, or the ringing room server. You're using Wheatley in ringing room, and the ringing room server runs the Wheatley command for you. Then this code gets initialized, and then we create the tower, right? And remember, tower is anything related to tower is talking to ringing room. And then here we have a massive block where we're basically attaching functions to be called whenever certain events happen. So we're like, oh, so tower, please, when a call is made, and specifically when look2 is called, call this function, please. And same for go, bob, single, that's all, stand. We haven't implemented the new calls yet. We could do that, in fact, if we have time. And importantly, the one that's of interest for us is that's all gets attached to the callback that we just saw. So if I jump to line 62 and we jump to definition, it jumps us back to here. So this is what will get called, and we can verify this by just putting a print hi, oops, no semicolons, and then run Wheatley. Let's just create a new ringing room. Oh, do I need to log in? That is pesty. Well, I mean, I'm going to have to do stuff. Right, so that I don't just like show all my passwords to everyone, I'm going to switch to just webcam for a second. Whilst, oh wait, hold on. It's fine. I didn't even need to do that. Where are we at? Here we go. Right, so we're back to ringing room, and everything's logged in. Blah, 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 blah. What room could we have? I believe I have aperture science. Here we go. Oh no, there's a Wheatley in this tower. Okay, let's hop into a different tower. Do not enter. That sounds about right. So now let's copy this and make, oops, wrong thing. We can make Wheatley join the same tower as us. So run Wheatley. Can I get the font a bit less squished? I think I can. There we go. Crikey. Run Wheatley. And this tower name. And what else do we want? Oh, let's just make method original. And this should join Wheatley. And importantly, we're using this thing here, which is run Wheatley. This is basically a clone of the Wheatley command, except that it runs the code that I'm editing here. Because the Wheatley command takes the code, installs it somewhere, and then runs it whenever you call Wheatley. Whereas this will call our edited copy. So I just thought I'd explain that. So now, if we, in fact, we could send this into the same window here. So we've got them side by side. And now we can see, if I press L.
Trouble's going and gone.
Oh. No, stand, please. Okay, that was, okay, wrong thing. What was it we were doing? That's all, wasn't it?
That's all.
Yeah, okay, so you can see it said tower received, that's all, and we printed hi, right? So we now know, and that hi came from here. So we now know that the callback is working, basically, which is, I use that so much. Like sticking print statements into code is so useful. There are probably more advanced ways of debugging, but this works. And so what's happening at the moment is that we have this flag called self.shouldStart ringing rounds. And whenever this is set to true, when this is set to true, the next backstroke, it reads all of these flags. That's like, how should I explain this? Okay, so at a very high level, right, if you're ringing, there are multiple states you could be in, right, in a kind of very mathematical sense of state. So you can either be just like, imagine Wheatley just like standing there waiting to ring, right, in which case we would say is ringing is false, right? So Wheatley is not ringing. This is kind of like the standing there position. And this is how Wheatley starts. It starts in the just standing, waiting for other people to ring. And then imagine someone says, look to, we're starting to ring. And now we go from just standing there to ringing rounds. Not any method, and we're ringing rounds. Or specifically, we're ringing the opening row, because Wheatley recently we added, or actually someone else added, some person that's not Matt and I contributed it, which is great. Thanks if you're watching, and thanks anyway even. So you can start with say 1, 3, 2, right, for practicing. If you don't want to start at rounds, you can start at, I don't know, some lead halfway through a course or something like that. So then you've got like the state. Oh, in fact, I could draw all this. Let's send that somewhere else. Can I just make a new whiteboard? Does this? Don't allow. Why would I? Okay, excellent. So imagine we've got like. Yeah. So does Wheatley know rounds as a method or is it a special state? Rounds is a special state. This changed a lot over development. Initially, the thing that decides the piece of the code that says what are we ringing, so part 2. Originally part 2 handled the going into and out of rounds, but that didn't really feel right, to me at least, right? Because it seemed like there was nothing special about exactly what we're ringing, that we need to go in and out, into and out of rounds. That's going to happen in any piece of ringing, and it doesn't have any relevance to method knowledge, right? Which is what number 2 is kind of all about. So eventually we split that out into Bob. So essentially we have a load of states. So we could have, I don't know, the kind of standing and waiting state. And this is where we start. So we could draw a little arrow that's like, Wheatley just goes from nowhere to mysteriously appearing in this state. And then nearly every call makes no difference here. Like if you call go when they're standing and waiting, then that should be ignored, right? The same with Bob, whatever. But in the case that look to is called, now we have to go to a different state. And that state, we're not standing and waiting anymore, right? We're ringing starting row. And, you know, in 99% of cases, the starting row will be rounds, so this will be ringing rounds. But we could ask for a different starting row, and then we have to handle the special case. So once we called look to, now there's another way back, right? That you could, if we're ringing rounds, and in fact, if we're ringing anything, and stand is called, then we go back, right? So we have like an arrow here that's like stand. And if stand is called, then we go back. Not immediately, we wait a bit, and then we go back. So there's a kind of time delay to all of these. But suppose that we're ringing, and go is called, right? So we have some kind of state transition. When go is called, we need to go into method. So we have ringing method. And note that, like, this doesn't always happen when go is called. It could be go or up, down, in, as well could cause this transition to happen. And again, there's another way back, right? Stand can go back to here. Oops, can I move this? No. Can I just edit this? Ah yeah, there we go. Not the most elegant way of doing it. But stand will basically reset to standing and waiting anyway, like wherever you are. And then we could go back here in the case of that's all or rounds. And in fact, this is not what happens. Sorry, I was cheating a little. There's in fact another state, and that state is ringing rounds. Specifically rounds, not necessarily the starting row. This is always rounds. We just like made the decision that Wheatley starts in whatever starting row and always finishes in rounds. If you want to have any other behavior, you just have to call stand in the middle. And so now we've got multitude of ways. We've got many ways to go in here. Like either method comes round and stop at rounds is not called. So like bang, stop at rounds. Or what else could we have? Well, if we call rounds as a call in the middle of the method, or that's all as well. We'll go into ringing rounds. And then eventually someone will call stand, and as usual, if we call stand, we just automatically return to this eventually. And I think this is a relatively complete picture of like how Wheatley's internal state machine works. Unfortunately, Python, with Python, we can't really implement this diagram as a diagram like this. We have to track it with flags, which is a bit annoying because you have like weird states where you're like, what happens if we're ringing method but we're standing out? Like, what are those? What does that mean? But I think the code works relatively okay. So basically, like at this point, we're like, and we're trying to fix this bug as well. So we've sketched this out to try and figure out what's going on at a high level. And what we're interested in is that's all, right? This is what we care about. And we're kind of interested in what happens during this state transition. And if we look back to the code, oh, why did it send it there? No, this, there we go, right. So we have these flags here where we're like, is ringing. And this basically determines like, are we standing or waiting, or are we in any other state? Is basically the upshot of this. Is ringing opening row is true if we're in this state, and is ringing rounds is true if we're in this state. So in fact, this highlights a bug actually, which is that this should start out as false. Because if you think about it, like it's just completely broken to be starting in, like, you shouldn't be able to ring rounds and the opening row at the same time. In most cases that will be fine because the opening row is rounds, but not necessarily. So I think this should start out as false. Drink time. Okay, so then we have to track more state than this, right? Like these flags are not enough, because if someone calls go, right, then we can't just immediately say set this to false and start the method, because that's just wrong, right? You need some kind of warning before that. I'm guessing this is all making sense, by the way. If anyone has any questions or anything, preferably not about which parts of my body I'd like my hands super glued to. So, yeah, if anyone has some like sane questions, then feel free to chuck them in chat. Oh, good. It is clear. I'll just take general silence as it's fine. So pretty much what we're interested in at this point is that we need, like back to the thread we were on, which is that there's some state somewhere that we have to track when calls have been called but haven't taken effect yet. Because, for example, if we call go, right, we would expect the method to start 2 rows after the call. Or rather, we expect it to happen the first time we meet a row of the right stroke, because we need to know the difference between methods, or like touches that start at handstroke and touches that start at backstroke. Like, you need to support that. And instead of what we used to have is what we have for like should start ringing rounds and stuff. This is a flag that gets set whenever that's all is called. In fact, we could probably search for on that's all. Oh wait, this is the thing that we're looking at. I remember. And this basically just says, next time we meet some condition, right? Oops. We should, yeah, so that's all has been called, and therefore we make a note of that. We say that we should start ringing rounds sometime. Not necessarily right now, because that's not what we want. We want to wait a little bit and then start ringing rounds. And then at some point, this gets turned into the actual flag. So if we just search again for start ringing rounds, it appears, 4 out of 5 times, that's a lot. And here we go, this is where it gets set. So we have the is ringing rounds flag, and we check every hand stroke. So this is at the start of every hand stroke. So this code gets called, you can imagine it's getting called in the hand stroke gap, if you like. And we do stuff like, if we should stand, then stand, and reset the flag. And if is ringing, and then we stop ringing, right? So if the flag should stand is set, then we reset it to say, oh, we don't need to stand anymore. And then we actually take the effect, which is to set is ringing to false, and this will make another part of Wheatley that handles like this switching in and out of ringing thing. It will make that go, oh, we're not ringing anymore. We should go back into the state where we're just standing and waiting. And then the one that we're interested in is this, which is that if that's all has been called, we should start ringing rounds, and we're not currently ringing rounds, then we should set the flag back to false, which is usually what happens. Like, we say, oh, we don't need to start ringing rounds anymore, and then we say we set is ringing rounds. In fact, I think this might be a bug. I think, oops, oh no, what's going on? Ah, here we go. Okay, so I think this whole bit of code here, I think this is a bug, because here we're checking, we only set should start ringing rounds to false if we're not already ringing rounds. So what I think will happen, if we were to run Wheatley, and then if we were to start ringing, so say look to,
Troubles going and gone.
oh, actually, you guys won't be able to hear this, will you? Right, can you hear, you can hear the ringing now, right? I mean, I'm not going to let Wheatley ring rounds for ages. Oh, in fact, hold on, this will sound awful. This will sound awful because you can hear it through my mic as well. Anyway, so we've got this, and let's say we call that's all, and then immediately say go. I think, yeah, exactly, right? So that's not what we'd expect. Wheatley basically just ignored the go, right? And that was because, if you think about it from the code's perspective, we had this, right? We had this check, and whenever we call shift n, yeah, here we go. So whenever that's all is called, it always sets the flag. It always says we should start ringing rounds, right? And even if we're already ringing rounds, that's the point. So when I called that's all, right? And we can see the log here, right? Which is that we're ringing rounds for here. We call that's all, right? And this code gets run. We set should start ringing rounds to true, and then we call go, and then we, 2 blows later, so for this round, we start the method. But we start the method and it is ringing rounds, right? Like, we suddenly have a situation where this is true, right? Because we set it true before the touch started. And then we at this point just, we check, oh, is ringing rounds, is this false? Of course it's false, right? Because we just started the method. And this code doesn't really care. Like, this doesn't check when that's all was called. So it says, oh, that's all has been called and we're not ringing rounds, therefore we should start ringing rounds again. And it basically undoes the effect of go, because go gets called, this flag gets set to false, right, to say, oh, we're not ringing rounds anymore. And then it goes, oh, hold on, we've rung rounds. And so I think if we just delete that in its entirety, this should have a better effect, right? Because at this point it will say, we'll call that's all, and the next hand stroke, which I know is not, like, this is not what we want, but the next hand stroke it will go, oh, we're ringing rounds. Or in fact we could do even better, which is that if we are here, we should just check if self dot is ringing rounds. Oh, yeah, I think, yeah, no, I think this will have the right effect, I think. But this is not really the bug that we're intending to fix. The bug that we're intending to fix is the fact that this check is too naive, right? The just checking for the hand stroke is not good enough, right? Because first of all, you could have a touch that comes round at backstroke. No, sorry, yeah, so it comes round at hand stroke, and therefore the next row that isn't rounds has a hand stroke. That does happen, not very often, but it does happen. And in that scenario, we need to deal with that differently. And this also just always waits until the next hand stroke, even if it was called, that's all was called during rounds. So we need to do something a bit fancier than this. And do we get to see what the right, so we need to figure out, we need to know what the new row is. Right, so I've already done this. So has just rung rounds tells us whether or not the row that we're finishing is rounds. And we can just put a check here that's like, if has just rung rounds, print, I don't know, something like we're stopping. And that will happen at the end of the method. And we could do something else, like cross minimus isn't a word, but I think we can now ring from place notation as well. And let's ring 8 bells and cross. So now if we call look to and then go immediately. And we go back to rounds. And then we're just looping forever. So I'm just going to kill Wheatley. And then we can see here that it says we're stopping. In fact, it says we're stopping even when we're not in the method as well. But it's basically whenever we're finishing a row that is rounds, it prints we're stopping. So we can just see that this is doing what it's supposed to. So now we need to, instead of just naively checking self.stroke.is hand, we need to do something better. Like we could also do some kind of check, like if or if has just rung rounds, and this is probably another good check that we can do, right? Because we shouldn't call that that's all. Now that rounds is a separate call, then that's all should just like only stop when rounds is reached. And this will handle like very, very early that's alls. Although also it's like not very good because you can't undo, you can't say, oh, I didn't mean that call, right? If you call that's all, Wheatley will stop at the next rounds. It could be like you could be ringing at the 7:20 in a quarter peal, right? And then like 20 minutes later, the flag should start ringing rounds. It's still set, and then we hit has just rung rounds, and then we stop. Right? And that would be bad, right? Like if someone's ringing a quarter peal with Wheatley, they need to know that Wheatley's not going to just randomly stop after the 7:20, because that would be terrible. Like that's just a waste of people's time. And I don't want to have that on my conscience. But there's something better that we can do, and we can do something similar to what we did up here, which with this giant comment here, and the rounds left before method. And this handles basically the same thing, but for starting methods, right? So we've got a scenario where we need more information than just what the stroke is and whether or not the call has been called in order to decide whether or not to finish. How is the lighting, by the way, on my webcam? I think it's fine. I could have some more light because it's getting a bit dark in my room. And the sun's setting. Anyway, okay, so what I think we should do, like what my plan was when I was like thinking about this bug to start with, like when I was making the issue, is that we should start ringing rounds instead of having this binary flag that's like should start ringing rounds. We should replace this with rows left before. What do we need? We need rows left before rounds. Does that make sense? And this is an optional int because it starts as none, which is basically saying, oh, well, none is kind of the representation of infinity, if you like, right? Like there are infinitely many rows left before we have to come round. And because if we're just starting the ringing and no one's called that's all yet, then obviously we should wait, right? Like, yeah. Whenever this is none, we're like infinitely far away from rounds, if you like. The same applies for this. Like, if this starts out as none, then we're infinitely far away from starting the method. We're basically waiting for some kind of input that changes this from none to an integer. So now I've got that. We're probably going to get some messages. Or if we search for this. Oh, that's annoying. I expected it to be like, oh, should start ringing rounds is not defined. But anyway, we now need to just check this manually. I'm pretty sure Pylon will take issue to this. Oh boy, oh boy, oh boy. Okay, no. Okay, anyway, ignore that. That was just like going crazy. So what are we having here? So we're setting should start ringing rounds to false, and this is look to has been called. So this is if we just oversimplify for a second, or simplify a little bit, look to has been called. You can imagine it being called when look to is called, right? In reality, this is not the case. This could be called a couple of seconds after look to is called, in which case we'll pass the time that we heard look to into here, and it just kind of predicts where the end of where the end of Bryn saying look to is going to be from that. That's just a technicality of like how the ringing room version works. And so here we have to initialize a whole load of things. And somewhere along here also we should set, I'm not sure, we should probably set rounds left before method to none as well here. Because once look to is called, it doesn't matter if people have called go before look to. Do we want this? What do you guys think? Should Wheatley allow people to call go and look to in the wrong order? Because I don't know. On the one hand, it's more flexible. Like there's no point. Like people could do that by accident and just get the call slightly the wrong way around. But the thing is, I'm not sure if human ringers would actually deal with this very well. What do you guys think? Do we, let's say I call go, then look 2. Should Wheatley start the method 2 rows into the thing? Like, should that be the same as up, down, in? That's the question. I mean, I'm tending to say that it should be okay. I don't expect it to ever appear. Like, I don't expect that to ever happen, but I don't think we should explicitly set this. Because this would remove the effect of go being called. But now, yeah, I'll leave another couple of seconds for people to reply and see what people think. So now we've got to remove this because this variable doesn't exist anymore. This will be a runtime error. So let's say we've now got to do something. Like when we start, we need to say rows before row left before rounds. Oh, that should be called rows left before rounds. Invalid position for rename. Ugh, the Python thing is so annoying. Python's language, like autocomplete, is so much clunkier than Rust's, which is what I'm used to. Anyway, that's an aside. I won't rant about languages. So rows left before rounds. Well, this should be set to none, right? Because we haven't even started the method yet, let alone called that's all. So we should set this to none when look2 is called. When's the next? What was it? Should start. Ah, okay. So on that's all. Now when that's all is called, we can't just set this Boolean flag to true. We can't just say, oh, sometime in the future we should start ringing rounds. We need to be more specific. We need to say rows left before rounds is 2. And I think this has to be 2. I can't remember what rounds left before method. What's this set to? Yeah, this is... Okay, so this is set to 2 or 3. Okay, yeah, this is right. And what are we looking for? Rows left before rounds. And that's set here. Okay, so we set that. Now we set it to 2. Okay, that's correct, because when... So you're about to ignore go before look2. I'm not so sure. I think if no one else has a strong opinion, then I'll probably go with ignoring it. But the thing is, it feels odd to make a special case for something, like to go out of my way to remove a possibility, right? Unless there's a very good reason why that possibility is like objectively wrong. In a way that I don't think this is. It is my view on the subject. Because like this is a kind of principle of software design, really, which is that there should be no arbitrary restrictions, right? Or as few as possible, right? Obviously, life is a compromise, so you're going to have some. But this seems like explicitly ignoring that case seems like an arbitrary restriction. But I don't know. Well, we're gonna edit the code next to it later, so we can decide again then. So that's all has been called, and we say, there are 2 rows left before rounds. There are explicitly 2 rows left before rounds, right? Like at this point, we're saying, oh yeah, 2 blows after that's all, 2 rounds after that's all is called. We need to stop ringing rounds. In fact, I wonder if this... this should be set to 2. I was just doubting myself a little bit. I think... No, okay, we're searching for the wrong thing. So what is it? Should start ringing rounds. Right, so this is the check that we want to remove. How many more have we got? We've got 2. Okay, so this is the only place left where should start ringing rounds is currently. Oh, okay. So there's another vote for Go being ignored. Okay, I mean, you guys now outvote me, so looks like we'll set that. But let's keep going, because I tend to jump around a lot before, like whilst on stream, which is probably harder to follow than it needs to be. So we basically want to do something similar to this, right? So the starting method code has a similar counter. So we want to do something akin to this for this check here. In fact, we could split this if statement, if next stroke dot is hand. Oh, yeah. Wrong thing. Lol. Right, so we split this case separately, so now we can edit this, and then we can just combine this statement here. Oops, I mean this and. So in this scenario, we want to replace this big long check here with something more sensible. The result is the same, right? It should start ringing rounds. We don't want to set this in the end. We want to say rows left before rounds is none. Because if we do actually have the effect of stopping ringing, then we should not leave a counter. And obviously at every time we start some rows, we need to decrement the counter. So we need to say, oh, another row has passed. So if this is, and this should say rows left before rounds. Another row has passed. If we haven't reached 0 yet, then we should subtract 1. And then we'll just make sure that this counter thing actually works. So, in fact, I think we have multiple cases here. We have the first case, which is the scenario where someone calls look2 and, sorry, that's all, and the method actually ends in rounds, right? And in that case, whatever value self.rows left before rounds is, yeah, so if imagine we're back to the scenario, do I have a whiteboard? No. In fact, I should do a print screen here, because this would make, without the circle, this would make good documentation for Wheatley. So I'm just going to take a cheeky screenshot on my way past. Let's just create another whiteboard for our scenario. Don't allow, why do you need my webcam anyway? So in the case where we have 1, 2, 3, 4, 5, 6, or we've got 1, 2, 4, 3, 6, 5, right? Because we're about to come round, and then we end up at 1, 2, 3, 4, 5, 6. So in the case that look2 is called, imagine it's called in the middle of here, right? I'll say LT. No, sorry, we're talking about that's all. So TA for that's all. So imagine this is the case. Now here we set the counter. I'm going to call the counter C, right? And C corresponds to rows left before rounds. So we say C equals 2. And then at the end of this row here, we're starting a new row. So this whole chunk of code here, start next row gets called. So if I scroll down a bit, we end up calling this code, which is oh, that's all has been, we need to check, we need to potentially start ringing rounds at this point, right? So then C is set to 2. And then here we go, we're starting this row, and we're oh, well, what do we want to do here? Well, we actually don't need to change anything, right? Because we're starting rounds, and it doesn't matter that Wheatley thinks this is still part of the method. It's still rounds, right? So in between the two rows, I'll just write it here. We do C minus equals 1. Right, so we decrement the counter. And then at the end of this row, or rather at the start of this row, at this position in the reading, as we would read English, C is 1, right? And this is like saying, oh, there's one row left before we have to be in rounds. And then when we finish this row, we're going to have another... Can I just get rid of this? Delete, does that? No. Bruh, I don't want this. Can I just make that really small? Okay, come on, let me edit the text, please. Oh, here we go, right. So now we've got 1, 2, 3, 4, 5, 6, right? We've got more rounds, and this is what we want. So, although in fact, in the code, we're kind of, so that's all's been called, we set C to 2, we ring this row, C goes back to 1, we finish this rounds, and then we're kind of in this starting a new row region, and all of this code gets called again, right? And now we go, what we want to happen is that this is rounds, right? Although we don't actually know yet what the next row is going to be. It could be the next row of the method, potentially. But if that's all has been called, and we've just finished ringing rounds, then remember that, yeah, so if that's all has been called in living memory, right, like in less than 2 changes, then we need to start with rounds. And remember at this point that we decrement the counter, currently we decrement after the check, right? So we do some check and then we subtract 1. And so when we actually do the check, C will be 1. And then by the end of the check, when we start rounds, C will be 0. So we want the transition to happen here before C is 0. And in fact, I think 2 is the wrong number here. I think this should be 1. Because imagine the scenario where this wasn't rounds, right? We had something more like, excuse me, no, I don't want, is this the delete thing? Oh, there we go, right. So I want to, no, I don't want to delete this. Can I edit this as text? Ah, here we go, right. So imagine we were at, actually, in the end, I don't want this. I want more text. So imagine we were in a different scenario, right, where we're like 2, 1, 3, 4, 5, 6, and then 1 row later we're back at 1, 2, 4, 3, 6, 5. I don't know, like maybe this is plain Bob or something, and then we've got 1, 2, 3, 4, 5, 6 here. And let's imagine we have the same scenario where that's all is called somewhere in here, and then C is set to 2. It's decremented to 1, and then it's decremented to 0 here as well, right? And therefore Wheatley would stop at this point, because we'd do the last check here and say, oh, at this point, from here onwards, C has hit 0, so we've got to be in rounds. I think this is too late. I think, like, what do you guys think? Do you think calling that's all this early should be allowed? Probably it should, actually. Because technically, I would expect that's all to be called around about here. Or maybe, like, I would probably call that's all at the end of this row, right? Because you need 1 row warning. The row that people actually need to change is this one here that I haven't written out. This is when people actually have to make a difference. So I would expect that's all to appear somewhere along here. So I don't know, maybe this is okay. I think this is probably fine, because this is still close enough to rounds that, like, this could just be, like, this could plausibly be just a very early that's all. So I think 2 is the right number. I think any higher than that, and it starts getting a bit ridiculous. And, you know, this is seems like a sane thing if, for example, this wasn't about to come round and we just called that's all in the middle of a method. In fact, what should that do? What do you guys think? I agree. You agree. Excellent. John Stern agrees with me. That's nice. So, yeah, there's another open question, right? Which is what should Wheatley do if someone calls that's all in the middle of a piece of ringing? Right? Does Wheatley stop? or does Wheatley continue? That's basically the two things. Because now that there's a call for rounds, like explicitly call for rounds, I would probably say that if you want the touch to stop in the middle of a touch, then you should call rounds rather than that's all, to avoid confusion. To avoid, like, I don't know, people accidentally hitting the H key in the middle of a quarter pill or something. Because I know people have rung quarter peals with Wheatley, and which is incredible. Like, well done, people. I appreciate it. But I think that's a legit scenario. Although, you know, it's only as safe as rounds is, right? Even if we say, oh, in order to make it come round right in the middle, you have to call rounds. Then we're still, like, people could press R by accident. And I think H is probably a less easy key to press. I don't know. I think probably consistency is more important. Because Wheatley's always stopped in the middle of a touch if you call that's all. And I think it would be confusing to people if that changes. So I think inertia keeps us doing the same thing. So, yeah. So basically the upshot of this sketching is that setting the counter to 2 when that's all is called does actually have the right behaviour. Which is that at this point, if we were... Let's create another text. Let's say we were just in the middle of some method. 4, 3, 2, 1. Let's say we were ringing plain bob here. Do we 4, 5, 2, 3, 1. And then, I don't know, I think this might be the plain course backwards. 4, 6, 2, 5, 1, 3, right? So let's say that's all was called here. That's all. That's a point. How do you expect to end half a course of Cambridge? I mean, that's all is a perfectly... that's all... Yeah, I think that's all is perfectly reasonable. It might not be what I would do in that scenario, right? But it is... I think it is a perfectly reasonable thing. It should be allowed, right? Yeah, no, I think that's a very good point. I think that clinches it in favour of that's all stopping touches in the middle. Because Wheatley doesn't know... Like, I guess I could hard code stuff like half a course of Cambridge, that kind of thing. But the thing is, that's too... like, I care more about Wheatley being predictable than I do about Wheatley being as smart as possible. Because smartness usually directly contradicts how easy it is to predict what Wheatley's going to do. And I think that's all should just stop. The question is, how many rows should Wheatley keep going, right? So if you call that's all halfway through some row in the middle of a piece of ringing, right? So we set the counter to 2, and then the counter gets decremented to 1. Horrible handwriting. 1 C equals 0, right? And at this point we get... Yes, yeah, John Stern says smart is equivalent to complex. Yeah, I'd rather Wheatley be simple and stupid than... well, yeah, because basically there's a kind of pressure between making something complicated in the hope that you do it in the right way. Like, making something complicated and smart can sometimes be useful. If you have a very, very good idea of what people are going to do, then that basically amounts to making your software opinionated, right? It has an opinion about how it's supposed to be used, and you optimize for that usage over being more general and predictable. But I think in this scenario, having some fancy check for like, oh, could this actually be forced round is too unpredictable. Like, and also Wheatley's been behaving like this for so long that I think it's not worth doing it. So the question is, yeah, so I think forcing rounds when... I still think that 1 is the right number. Because imagine that we set it to 1 and then reach 0 here. We would force rounds from this point onwards, right? Which is fine because we're just overwriting with rounds that comes from a method with rounds that comes from rounds, right? This would be indistinguishable. Whereas in this scenario, setting it to 1 and 0, it has the right effect, right? Which is that from this point onwards, we ring rounds, because one change has elapsed since that's all. And then if we're in the middle of ringing, then that's all is called, and then one row later, Wheatley stops. So this would be rounds. And there'd be some... Oh no. There'd be a weird jump at this point. I'll just delete that. Yeah. Why is this so unpredictable? Is it this tool that makes me go into... This seemed to work at some point. Oh well, anyway, this would be rounds. I can just cross it out. Rounds. Ugh, my handwriting is properly childish. Yeah. So I think setting it to 1, we either set it to 2 and decrement the counter before the check, or we just force it. We force rounds. We want to force rounds to happen 2 rows after that's all. And I think that's the remainder of this one. It is like, I don't know, a half. And then the full of extent of this one, which is 1.5. So I think it's like that there'll be one row that's not necessarily rounds, and then from then on there'll be rounds. I think that's the right scenario. What does anyone else think? That, yeah. Does anyone think it should be the other way around? That you should have like one more row of leeway? The problem being that if you call that's all partway through rounds, which is what people have, which is what is causing the whole problem, right? So we have 1, 2, 3, 4, 5, 6, and then the next row, like someone calls that's all in the middle of this. Actually, wait, hold on. Actually, hold on. Yes, that's right. The only problem is we need a special check for if the method came round in the first place, then we need to... Yeah, no, so I think that's right. You do this, and then you jump to rounds 1 row later. You finish the row, wait a row, and then jump into rounds. Unless rounds actually appears, in which case you jump to rounds anyway at that point. Because then we handle a scenario that's all is called midway through rounds. So I think in code that would look something like, when are we doing the check? So if either self.rows before rounds, if this is hit 0, then we start rounds. Or we have another scenario, which is that we're partway through ringing, and if we have just rung rounds and self.rows left before rounds is not none, either of these scenarios we should stop and then do the decrement. But I think this should be no, I think we should be consistent. So let's do this. Let's put it so that the line isn't really long. The comment needs to be changed as well. So if let's just leave ourselves a comment so that we don't get confused later. There are 2 cases for coming round. One, we're in a method. Yeah, so someone calls that's all, and rounds appears. Yeah, so someone calls that's all, and rounds actually appears. Stop immediately. Or someone calls that's all, and 2 two rows elapse have. Oh yeah, so one clear row has elapsed. So one clear row. Yeah, we've got this case. One clear row has elapsed. Stop. Ringing. Ringing method. Okay. And then we need a comment in here that's like or. Yeah, because we basically only stop at rounds if that's all has been called. This check will stop rows left before rounds ever going negative, which would be a bit of a that would be a bit of a weird case. I mean, I guess that's just the same as it being none, because it will never reach 0, but what would it? Oh, it would be a bit broken because we do this not none check, which would pass. Anyway, right, so this should be... Yeah, okay, so we've completely replaced our old code with some new code, and hopefully it should work. So we can try and test this. Can we ring cross? Maybe cross is not the right thing. Let's ring plain hunt on 4, but with people dodging. I think that's a decent middle point between not coming around immediately and like what am I trying to say? My brain's just run out of. I've just got myself confused. Anyway, let's just run Wheatley with up down in as well, because that's just convenient. So basically, we've now got to test the cases, right? Which is that we call that's all during rounds. It should just stop immediately. So let's test that first. Right, and now we're into plain hunt on 4. Right, so this is rounds. Oh, yes, okay. So that was the bit where it was getting confused earlier. So we're now back in rounds, and what are our other scenarios that we've got here? We call it the row before rounds, then it should just stop. So let's do that again. Right, so this is the row. Oh, and we're back in rounds. That's excellent. Right. What are the other cases? So we've done this case. We've done the rounds case. So we've still got the case of like randomly halfway through a method. So let's go again. And then if you just call that's all. What? I swear that didn't work. Am I just like imagining things? Because that should have... I called it at the backgrounds point, and that should have just jumped into round straight away. Let's try that again. Right, so we've got backgrounds. If I call that's all... No, this is not, that's not working. That's not working at all. Right, let's just stop Wheatley from ringing. Okay, so what's happening here? So we fixed some other cases, right? So we've got let's have a nice green tick over this. We've fixed this case, we've fixed this case. And I also checked. Oh, I didn't check the very early that's all case. We could do that as well. Let's just run Wheatley again.
Trebles going and gone.
Yeah, okay. So that's the behaviour I'd expect. Stand. Right, okay. So that's the behaviour I'd expect. But it looks like this check is never getting run. For some reason. Which is odd, right? Because we start at 2 and then we keep decrementing a counter and it never seems to be triggering. So let's just print rows left before rounds. Let's send this to the same screen. Same screen. Oh yeah, there we go. So now we can watch them side by side. We can watch what's going on. So we're looking for the case where rounds happens in the middle. Yeah, so if I just call that's all here, right, it gets 2, 1. Wait, hold on, it did work. What is going... Am I just... Oh, I didn't mean to do that. Am I just going mad? Am I just missing this the whole time? Right, because it starts ringing method. Ah, okay, I see what was happening. Alright, let's just stop. So it seems that the delay was too long, right? Because I didn't notice, because what we essentially just had was a jump change, right? We jumped some bells into the right place and rounds happened. So the difference between this row and rounds was very negligible, where I called that's all in the thing. So I think this is telling us that 2 is too big, right? We need... do we want it? Yeah, because all of these cases are still satisfied if we start at 1 and say that, like, you know, it's one clear row before that's all. Because if we call very near the front of a row, then it's a bit confusing. Or we just check for... no, so we should just check for it reaching 0, not just, like, saying this is less than or equal to 1 is just... it just doesn't make any sense from, like, what does rows left before rounds actually mean? So I think we should... there goes the rows left before rounds. Where is this defined? No, so it's defined here, also set here, and then... Oh, in fact, this was this place where we should also set rounds left before methods to none as well. This is what people were saying, that we should ignore go, because if go is called before the method, before look 2, then look 2 should reset rounds left before method. Oh wait, actually, hold on. This is done directly afterwards anyway. It's set here. Oops. Okay, right. So we've got that anyway. Let's see. So I think this should be set to 1. We set this to 1 because look 2 because we expect one clear row between the call and rounds. So I think this should behave the same way in all of the cases we expect, which is, I hope you don't mind the monotony of playing Hunt and 4. Okay, so that case worked, and that was called part way through the row before rounds, right? So that was, get rid of the ticks. That was, can we get our, oh, we just lost some of the rest of the drawing. So that was the case. Yeah, I think, yeah, Roger, I think you're right. Because that was working. Ooh, that's spicy. I've never seen this happen before. When I press Control-C and it says corrupted unsorted chunks. Nice. Okay, well, so we've ascertained that this scenario works. We also have the super early that's all and the that's all in the middle. I'm pretty sure calling that's all at the end. Let's just ring this, because this will be even quicker. So basically plain hunt on 2. So if we call that's all partway through rounds, right, it does what we expect, right, which is that we start rounds. And then if we go again and call that's all 2 blows before rounds, so that would be in the 1-2 near miss. Then it should also come round where we expect. Right, so that was another case that we've got, which is that this late case here also works, and the case that we have and can't see anymore, right, that's rounds, also works. Where are we? I think we need something slower. Let's just ring original mate. Oh, place notation. Well, let's just give it the place notation. X18. Set. Look to. And then let's just test what happens if we call that's all right in the middle of some ringing. Yeah, so I think this is perfectly valid behavior. Like that delay is okay, right? I think. Does anyone else think that we should have more delay, right? Because there's one clear row and then back to rounds. I think this is what most humans would do. Oh yeah, we can. Oops. We can send this back to the other place here. Nice, excellent. So I think we fixed that bug. Let's close Vim and then see what changes we've made. We shouldn't have made very many actually. This was changing this plus for a minus. This was simply a small tweak, right? That has no effect. That's just ringing rounds and the opening row at the same time is weird. So, and then we replaced this flag with starting round that starts out as null, none, and this is in look 2. When look 2 is called, we set it to none. That's like, oh, we ring an interminable number of rows. We have an undefined number of rows left before we ring rounds. And whenever that's all is called, we set this to 1, because we're like, we want one clear row before we get that's all. And this is the last change, which is we replace this is hand stroke test, and replace it with this more complicated check that like, oh, we either run out of rows and then just force it to come round, right, because we're in the middle of a method or whatever, or we have just rung rounds and someone called that's all less than 2 rows ago. And then we have to decrement the counter as well. Otherwise, it will just get stuck at 1 forever. I mean, having a counter at all is just kind of mad for the fact that it'll only ever be set to 1 or 0, right? But this is having the counter is very flexible. So I think this is good. We need to let's make a pull request for the changes. So we're on the master branch at the moment. If we look at the commit graph, this is basically every time the code has been changed. And on the left here, we have this column of like bars. That's like the master branch, which is... The counter could be a Boolean, right? But the thing is, we could have it as a Boolean that's like, it's either true, false, or none, right? It's like false because we're waiting a row, or true because we should come round, or it's none because that's all hasn't been called. That would be equivalent, right? It would do exactly the same thing, but I think it would be less easy to read and maintain, right? Which is a factor in its own right, right? Like if the code works but is unreadable, then we're very unlikely to be able to keep it working, right? Because, like, with the best will in the world, like, no one's perfect. And we do, like, peer review all of the code changes. Like, Matt and I will always check each other's code before it gets merged. So, like, checks happen, but also, if we write the code in a way that's not... Like, you want the code to be as clear as possible. Unless there's some, like, performance reason for it. In which case, it's okay to obfuscate the code a little bit in the name of, like, making it really fast, right? But, you know, Python is slow enough already, right? Like, if we want Wheatley to be absolutely top-notch fast, which is pointless because it doesn't, like, it spends so much of its time waiting, then we would write it in a different language. So, yeah. The upshot is that the counter could be a Boolean, but we want it to be a counter. So what we need to do is we need to switch into a new branch. So we need to stay at the top master branch, which is like, master is like the ground truth of what the code is. And if we look at the graph, you can see master is still pointing at the last merge, right? Which is, when I changed the README, right? And we have kind of some imaginary changes on top of this that we've made. So we need to git checkout onto a new branch, and what should we call this? Like better, or yeah, let's call it that's all fix. So we switch to new branch, and if we look at the status, we've still, Git doesn't know, like the version control doesn't know that bot.py has been changed. So we need to check in our changes. So we can, probably the easiest way is to say git add bot. And now if we look at git, then it's like, hey, I now see that this has changed, but we haven't named this change at all. We haven't named the new state of the code. And in order to do that, we make a new commit. We would say commit-m for a commit with message, but I have that shortened to cm, which is non-standard. That's a custom thing. As is git st actually. This should be git status. But anyway, so now what should we say? We let's say implement correct behavior. Yeah, make this shorter. So like make that's all more intuitive. Yeah, so now Git says, oh, no changes have happened. And if we check out the graph, which again is git gr is another alias that I've made, we can see that master is still here. It's still at like changing the README. And we've made another change on top of this, which is that that's all is made more intuitive. But the thing is this is still on the branch. This is like a branch of master, right? We've made some changes, but we don't want to check them straight onto the gold standard branch because we want, I want Matt to have a look at them. So what we'll do is we'll make a pull request to say like, hey, which should be called a merge request. And we'll say, hey, I want to merge these changes back into master so that they become ground truth and will get released in the next release. But it gives Matt a chance to look at it and we can run a load of checks on it. So I'm pretty sure we need to I think we need to update the linter. So pip install upgrade pylin. Right, excellent. And now we have .run. Huh? Did we not? I'm confused because I'm pretty sure in the code repository, let's just overwrite this, we have run checks.py, which does all of our checks. Why is this? Ah, because we're in the Wheatley folder. That's why. No development branch. No, we just commit straight to master. And master will always be ahead of the latest release, which you can see. Master is our development branch, if you like. If we look at the graph, you can see that we've tagged a release onto the master branch. So I've said 0.7.0 is the first beta release of 0.7 is this commit here. So now when we make changes on top of that, those won't be released until I make a release, right? And this just stops us having loads and loads of branches and having to keep track of which features go where, right? Like if you want to make some changes, you check out master branch, you make some changes, you check them back into master. And you can see here, like we, 0.6.0, the last release was here. And then if we really need to, oh cool, yeah, you can see the tags. So if we really need to hotfix something, like, oh, we find a critical error, like Wheatley starts crashing or whatever, which has happened, and we need to roll out a release, then we can say, oh, well, I don't want to release all of these changes, right, because these are new and we haven't tested them yet. So we would make a branch off this point, right? So it'd be like, oh, we've got master, which has all our new changes. We would commit the new changes onto master so that they work. And then we'd make a new branch off here that's like the 0.6 release. That's a branch away from all of our development. And then we'd cherry pick the extra changes we'd made across. So we're like, oh, I've made these specific fixes that's like hot fixing or whatever, like changes the crash, like fixes a crash bug or whatever, changes some dependency versions, whatever made the fix work, we move that across to the other branch, and then make another release. So we'd make 0.6.1. But it, like, this way, I can't remember what it's called. Matt had a name for it because we had a discussion about how the branching structure should work. And I think this is called like trunk-based development because we have a trunk. It's called trunk in Ringing Room's code actually. And everyone just branches off the trunk and goes back into the trunk. And then if you really want to keep a version going, then you make that a branch off the trunk, right? And then that's your special case, rather than like your day-to-day development being a special case of maintaining a branch, right? That doesn't make so much sense. But anyway, let's push this to the, like, on the internet copy. So this will make our changes that we've made to the local Git repository, right? So I've made some changes on my machine, and I've turned them all into this branch called That's All Fix. I really want the apostrophe, but I don't think Git would take that very well, having apostrophes in branch names. So now I've made it up to date with my own copy, but we still haven't gotten into the master branch yet. So now we need to go to GitHub, and then it says, oh, That's All has recent pushes. So we compare and make a pull request, make That's All more intuitive, and we can link it to the issue that we have, which is this one, which is 103. Fixes number 103. And this will make it so that so this saying this makes sure that when we merge these changes into master, it will automatically mark this as fixed, which is super nice. So we don't have to manage that manually. So fixes 103, that's all now behaves more as people expect. And we have the two cases as before, just like saying this for Matt's benefit. If we meet rounds within to clear rows, then stop. Otherwise, jump to rounds after to clear rows. i.e., your So, and this is an example of like killing a touch halfway, or as Roger said, half course of cams. I don't think we need to say more than this. Preview, create pull request. And let's ask for Matt's review, and that will basically say, oh, and now all of our pull request checks kick in, which we can run them on my local machine. So I think run. Do we have run checks? Run checks is not marked as executable. We need to change that. Plus X, run checks. Now we can run it as run checks.py. And this will just run a whole load of automated stuff. These are basically just sanity checks. So we've got unit tests, which is like little pieces of the code. Do they do what we expect? These documentation tests are, we run the examples in the README. So if we look at the README, we have a load of examples here. And when we were developing it, we would change like the names of these or whatever. So this runs all of those examples and checks that they actually work. And I've substituted a method name and a tower ID. And then fuzzing is basically whenever we have some kind of input that we could give Wheatley, like, you know, the call strings. So it can be like run Wheatley, some tower name, this, oh, start road, yeah, we were testing Dixon's. And like, I don't know, Bob. And we need this like custom call string that has to be parsed and like checked it's okay. So the fuzzing basically feeds parse call and parse peel speed. What's this? 100,000 random inputs, and it basically just checks that. It doesn't check that all of them succeed, because obviously they won't. If you feed garbage, you'd expect errors. But it checks that the errors are one of the small number of errors that we expect that are human friendly, and it doesn't just like go haywire. Linting is just generic checks for like, oh, have you assigned to a variable that doesn't exist, stuff like that. And type checking is, we have, if we look at the type annotations, say in tower.py, we give everything a type. So like tower ID is an integer, whatever. And the type checker just makes sure that those match up. So hopefully we can catch some errors before getting into production. And the type check passes, so these have all passed, which is excellent. And I'm pretty sure, yeah, here we go. So the checks that ran on, like, I don't know, somewhere out there in the cloud, I don't know where they exist, these ran and they all passed, which is good. Also, I should probably, yeah, but so I've also made another change, which is to mark this as an executable, because otherwise we couldn't run it with like /runchecks.py. So I think we should just check that into our thing anyway, just as another change. So we can say git commit with a message, make run checks.py executable, and that adds it. And it says changes the file mode, which is what we want. And now let's just git push, which will update the remote branch, and we can see we've made another commit here, and all of the checks are running again, and they'll pass because we haven't actually made any difference to the code. So I think we can safely just wait for this to change. So basically, like, and then at this point, what will happen to these changes? Well, Matt will review them at some point. He'll probably say yes, there's not much to review, and it's fairly self-explanatory. And if he doesn't, he'll request some changes, and I'll be like, oh yeah, I'll go and fix them, whatever. And yeah, and then we'll merge it into master, and it won't land in like a release until we explicitly make a release. And so at some point in the future, these changes will land in everyone's hands. So yeah, let's close all of these, close this, we don't need it anymore. Has this finished yet? Hopefully it has. Oh, we need to make this faster, it's so annoying. All of the speed is taken up. Oh, there we go, it's finished. All the speed is taken up by the documentation test, because it spawns a new process for every command that's run, and it doesn't do it in parallel. In fact, there's an issue for this. If someone wants to fix this, then it would be a nice, easy. It would be a good first issue, I think. Here we go. If someone out there watching wants to fix this, you don't need to know anything in the code to do this. It's just like the doc test thing is its own standalone thing, and I'd be happy to like answer questions and point people in the right direction if anyone wants to do that. But yeah, I think that's enough for stream today. I think it's been nearly 2 hours, and I was a little bit over optimistic perhaps that we would get a different issue fixed. But, you know, that can be for next month. We can have a look at how the rhythm stuff works and fix that bug as we go. Where is the thing? Don't wait for people being slightly late. It was this one that we were going to fix. But, yeah. You know, we can dig deeper into more bits of the code. But I hope this was an interesting thing, and hope that you all enjoyed it and learned something. Yeah, if you did, then that's great. And if you just like enjoyed watching, then that's great too. But anyway, we get to see a little wave machine. You can do some cool things like this and make waves, because it's recording my screen and then displaying the recording and then recording my screen and so on. Anyway, I digress. Yes, string length limit. Ooh. No. So Roger asks, is there a string length limit for place notation? No, there isn't currently. We should probably do something about that, actually. Although, to be honest, I don't expect anyone to be like feeding the output of one program into the place notation input of Wheatley. And anyway, it's not like we're doing something crazily computationally intensive on the place notation string. Why? What is it that you want to ring? What is it that you need such a long amount of place notation for? I'm curious. Because, yeah, it's another kind of, like, not useful... Like, it's another arbitrary limit, is the upshot. Anyway, I think I'm going to call stream here. I probably... Roger, if you're going to reply... like, if people reply to me, then I probably won't see it because I'll close stream and there's a huge delay loop. So stream will be carrying on after I've actually stopped. So if I don't reply to chat right at the end, then that'll be why. Nice. Okay. I mean, that makes sense. That's a fairly good use of the... I mean, you could do that anyway. You could make the lead of Bristol be a weird bob where it takes up an entire lead, but... I mean, it doesn't really matter. Like, in all honesty, you probably can't cause a crash by putting too much place notation into the place notation parser. I mean, the parser's really fast. It's like, well, okay, it's not really fast in relation to other languages, but, you know, like, it's just a load of regex matches over the string. It's not going to be, you're going to have to get really big, like, I don't know, several megabytes of place notation before before things start getting really hairy. And even at that point, I think it would be fine. But anyway, this is a digression. So I hope you all enjoyed the stream. I'm going to be doing these on the third Saturday of every month. Typical of Windows to have a command line limit. Given the chat response. But yeah, so I'm going to do these every month. I think that's a good tack in terms of like how much time you're prepared to watch, because these are quite long, right? And how much energy like it takes out of me to do them, because streaming at all is fairly exhausting, right? But I will keep putting making Facebook events. I should probably give more time than I did last time, right? Because last time I should make the event sooner. But anyway, I've had a lot on this week. What with other projects, like project for university, which happened to be to do with ringing. But I'll probably do some streams developing those once I've handed the project in and I'm not super stressed about it. Like once I have some time free to work on it, is the upshot. But yeah, anyway, thank you all for coming. I hope you enjoyed it, and I'll see you next month. So yeah, enjoy the rest of your day. Bye.